Welcome to Bodhana as part of lecture series. In this video, I am going to discuss about the introduction related to the lasers and optical fibers and its importance and working principles, etc. Coming to the laser point of view. Laser, that stands for light amplification by stimulated emission and radiation. So obviously here ordinary light comes with the principle of spontaneous emission, but here the laser stand abbreviation itself, light is amplified, that is amplification is nothing but increasing the intensity. That intensity can be enhanced because of the stimulated emission and radiation. So this total chapter is dealing about the importance of the laser light because of the stimulated emission and the radiation. But when it is possible, absorption and radiation is the two mechanism. Radiation is nothing but generally when it is in the higher energy state. When it comes to the lower energy state, the difference amount of energy is released, that is take it as the radiation. But absorption, if any atom or the molecule or ion, if it want to go for the upper state, then obviously it takes energy, that it take it as the absorption. So in case of laser point of view, we should discuss about the different scenarios. So coming to the first one, the speciality of the laser is possible by comparing with the ordinary light. So in terms of ordinary light point of view, in terms of intensity point of view, in terms of direction point of view, in terms of coherence point of view, or in terms of monochromaticity point of view, the laser is different compared to the ordinary light. It has high monochromaticity, high directionality, high intensity, high coherence. Just see, just an example point of view. Here I am taking one kind of laser here. This is a laser. So here when I show you, there is a very narrow beam of light is coming, and even by spreading also it can move up to this particular distance without any deviation. It is possible because of its directionality nature and intensity nature. At the same place, if I place ordinary light, it won't move up to that mark and deviates its path, that like called as divergence nature. So it's spread like this, but in case of laser, so the direction is very sharp and intensity is more. Because of this reason, it can go up to long distances without any deviation. But these characteristics like intensity, monochromaticity, directionality and the coherence, these characteristics is possible because of the stimulated emission nature. So as part of this particular topic, we need to discuss what are the different mechanisms related to the transition between the lower energy state to the higher energy state. In this way, we are discussing about the three. First one is the absorption. Absorption by the ground state atoms or lower energy state atoms because of the external energy supply. So that it called as stimulated absorption, because without external agent there is no possibility to absorb the energy by the either atom or the molecule which are there in the ground state. That's what it called as, because of external influence or the external support, that's what it take it as the stimulated absorption. Once the atom is going up, now the atom is in the upper state, so that can be possible in case of two ways. It can come either by its own or because of influence of external agent. If it is coming by its own, that is called as spontaneous emission. Mostly ordinary light, spontaneous emission can be possible because higher energy is unstable nature. It come back to the ground state to gain the stability. In this process, there is no need of any external support or external photon is required. The difference amount of energy is released in the form of single photon, that is taken as the spontaneous emission. But whereas in case of stimulated emission point of view, the external photon is interact with the higher state atom, and the higher state atom come back to the ground state with release of the two photon, these two photon move in the same direction. Constructive interference may happen. So once the superposition can be possible, once it can superimpose each other, the intensity may enhanced because the displacement is y equivalents to y1 plus y2, and a equivalents to resultant amplitude is equivalents to a1 plus a2. Intensity is directly proportional to the amplitude square. Because of its directionality nature, because of its coherence nature, superposition can be possible. Because of that, the intensity can be enhanced. If two photons are interact, 2a is the amplitude. If both are equal amplitudes, 4a square is the intensity. If the three photons are moving, then obviously its intensity value is 9 times that of the individual intensity of the light. But when you compare with the multiple photons or interact with the higher state atoms, we can expect many more number of photons are released. So in this process, the highest intensity can be possible. Some cases we can compare with the sunlight intensity also. So this is about the coherence, like a relation between the one point to the another point maintained strongly in case of laser light, like a phase relation or the amplitude relation is comparatively ordinary light, it is more. That's why its coherence nature is very high, and the complete coherence nature, like a spatial coherence and the temporal coherence, when we can consider the coherent sources, that part will be discussed in the extended videos. And coming to the here laser point of view, the pumping method in general, the main conditions to attain the laser or the stimulated emission process is, one is external support must be there, and another one, the higher state atoms must be present. So in general, the atoms, the lower state atoms are more compared to the higher state. But in case of laser, if you want to get the laser, the stimulated emission process need to be involved only because of the higher state atoms must be higher compared to the ground state. That generally, see here, the state of ground state atoms are more compared to the excited. Is the general process. Now what we are doing here, these atoms are pumping towards the higher state, and we are creating the more atoms in the higher state compared to the ground state. That is, we are creating the inverse mechanism of the population, that is called as population inversion. Population inversion can be possible by sending the atoms from the ground state to the higher state. This process of sending atoms from the ground state to the higher state to create the population inversion is called as pumping method. Etla pampistam? There is a different ways we can pump the atoms, either by using the optical energy or electrical energy, chemical energy, thermal energy, collision energy, or whatever the form of energy. If you are able to supply to the ground state atom, the atom may jump to the higher state. This is the general mechanism related to the pumping methods. And lasing action, just previously we discussed that external photon is interact with the higher state atom, and the atom come back to the ground state with release of the two photon. This process is called as stimulated emission. These two released photon won't reach to the ground, and again it interact with the two more atoms of the higher energy state, and these two atoms come back to the ground state with the release of the 4 again 8 again 16 again 32. The same way it can able to enhance the number. This process is called as lasing action. This process continue till the population inversion is possible. Once the population inversion is not there in that particular system, there is no further action is possible. This is about the lasing action. And one more concept, optical feedback. Optical feedback means this process, wherever this lasing action is done, that process takes place in between the two mirrors. So for example, one photon is released, one photon is interact with the excited state atom come back to the ground state, release of the two photon is moving in this way, and because of this mirror, these two photon again reflect back within the same material. These two photon again interact with the two more atoms of the higher state, it releases the 4 again 8, and again 8 reflect back. That means that number is increases in between the stipulated area. That process is called as optical feedback. That can be possible by taking the two mirror combination. You may get doubt, if every time it is reflecting into the medium, how we can get the output. So that is possible. One side is 100% mirror like, and another is a 90%, remaining 10% is transmitted. That means output can be taken from the 90% source. This is about the population version and the lasing action and the optical feedback. These are the important parameters to attain the laser or to obtain the laser light from the any material. But what kind of material we need to take? All materials won't satisfy the laser actions or the lasing conditions. Only particular materials can be possible to give the stimulated emission. For example, two level system, two energy level that material consists only two energy level, that material is not suitable. Only it can be possible either 3-level system or the 4-level systems. But 2-level system lasers are not at all suitable for the construction of the lasers. So, and what kind of material is chosen? Whether it is solid or the liquid or gas, whatever the material you can choose, if it is match the required condition, that can be used for the construction of the laser. Which material is response for this particular process is called as active material. Based on the active material nature, the lasers are further classified into the different ways, whether it is a solid state laser, gas laser, the semiconductor laser, or etc. But according to the syllabus, we have different kinds of lasers like ruby laser. Ruby material, aluminum oxide is doped with the chromium ions. There is a solid material, it's a 3-level laser. So the complete description is given in the particular video. Then helium neon laser, argon ion laser, CO2 molecular gas laser, helium neon is the first gas laser, semiconductor laser. So these are the different kinds of examples for the different varieties of lasers. It completely based on the material what you have chosen for the initiation of the stimulated emission process in that particular system. And coming to the applications point of laser has variety of applications in militaries, industries. Laser has highest intensity and highest directionality. Then intensity can be used to drill or to cut the metals, or it can be used for the army to collapse the aircrafts. So scientific purpose, many more applications. Even lasers are used for the medical application, laser treatments, etc. So the complete one by one, every topic will be discussed separately with complete information. This is about the lasers part, and in another video I will give the brief introduction related to the optical fibers. This is if you are new to here, I am Dr. Ramesh. Our intention is to create the complete set of videos for all kinds of subjects related to your BTech degree. Thank you.